Hello there. In this video, I'm going to go over the rational zero test. So in this video series of solving polynomials, I've gone over various techniques. But the problem becomes when you get more and more expansive on the types of polynomials you use. So quintics, sextets, and septets, and so forth and so on. Your options become very limited. Okay, there's plenty of options for cubics, quadratics. There's a few options for quartics, but the rational zero test is kind of like the big unifier. It is a universal method we can use on any polynomial. So, what is the rational zero test? The rational zero test says that if rational zeros exist for a polynomial, they will be of the form r over s, where r are the factors, or is a factor, I should say, of 3, or in this case 3, constant, and s is a factor of the lead coefficient. Okay? Now, if rational zeros exist is a very key part of this. If it doesn't have rational zero test, you can go through and do the test, just nothing will work out. Now, you may have heard this also called the Rational Root Theorem. I've come to know it as a rational zero test because I'd never heard of this theorem until I started teaching pre-calculus, and that's how the textbook referred to it, so that's the name I learned. That's what I use. So R is the factors of our constant. Our constant is 3. That's nice. That's just 1 and 3. But we also have to consider, well, -1 divides 3, so usually I'll write plus minus. And I always tell my students, you don't have to write the plus minus, but keep it in the back of your mind that the negatives are a possibility. And then S would be the factors of our lead coefficient. So factors of 4 would be 1, 2, and 4. And of course, again, plus or minus, and plus or minus. Okay, great. Now, how we set up R and S is just systematically going through one R and one S at a time. So 1 over 1, well, that's just 1. Okay. 1 over 2, that's 1/2, and then 1 over 4. Okay, great. So we went through all our S values for R being 1, so let's go through R equals 3. So 3 over 1, that's just 3. 3 over 2, and then 3 over 4. And once again, well, we could think through the same process with -1 and -3 and go through all that, but I mean, a positive over a positive is going to be a positive. Negative over negative is going to be a positive, and then varying combinations of pluses and minuses are going to give you a negative. So either way, you're going to end up with these options with pluses and minuses in front of them. Now, let's take a second to appreciate the beauty of this test is that we have infinitely many rational numbers. What the rational zero test is says all the possibilities can be whittled down to this formula. And now we only have 12 test subjects. But what do we do with these test subjects? Well, some videos may tell you to plug it in for X, okay, to test to C. And now, depending on what a question on a test might ask you, if you're going to test it, maybe it's asking you to factor the polynomial. Maybe it's asking you to solve, okay? I prefer to go the route of using synthetic division because synthetic division is something you would need to know in order to set this up in a factored form. So make sure you're up on your long division and synthetic division. If you would like to see a video of that from me, leave a comment in the comment section and leave a like. However, I'm not going to go through and test these. I'm just going to skip straight to the end and tell you that the test subjects we're looking for are right here and right here. We've whittled it down to 12 options, okay? It's not difficult to check these one at a time. It might be a little time consuming, but these are our possibilities, okay? But let's get familiar with the process and not get bogged down in extra detail. So I'll start with positive 1/2 and I'll set it up in synthetic division. And I'll show you why I like to use synthetic division as we get through. So 4, -12, 3, -9, -1, and positive 3. I'll drop my 4, and of course, synthetic division, we take 1/2, we multiply it by 4, okay? So that's 2. And then what we do is we add these two numbers together. Negative 12 plus 2 is negative 10. And we repeat the process. 1/2 times negative 10 is negative 5. We'll go ahead and add 3 and negative 5. That gives me negative 2. Okay, 1/2 times negative 2 gives me negative 1. And then we add negative 9 plus negative 1 is negative 10. 1/2 times negative 10 is negative 5. And then we'll add, we get negative 6. And then 1/2 of negative 6 is negative 3. 3 plus negative 3 is 0. And this is the result we want. Whenever you're doing this, if you get a remainder of 0, that means what we tried, the 1/2 in this case, is a 0 of the polynomial, a 0 or a root. Now here's the ultimate key of why I like to try this, is because now we've reduced the polynomial. We started with degree 5, and now we have a degree 4 polynomial as a result. Let's think about why this is important. I want to solve for all roots, not just rational ones, but complex and irrational. The options I've told you might be possibilities. That's 2 of them, and that's 2 of them. Well, unless there is multiplicity of greater than 1 with one of them, that only gives us 4 possibilities for a degree 5 polynomial, and a degree 5 polynomial can have up to 5 distinct solutions. So at some point, we might have to do some additional algebra somewhere else. Okay, so let's start with this polynomial on the next solution. Because if it's a solution of this polynomial, it'll be a solution of this polynomial. Okay, so I'm going to go with the negative 1/2 this time. Let's pick up the pace a little bit. Drop the 4. Negative 1/2 times 4 is negative 2. And then adding these two together, I get negative 12. Okay, negative 1/2 times negative 12 is negative 6. Add these together, I get negative 8. Negative 1/2 times negative 8 is positive 4. Actually, sorry, whoa. Backtrack. Beep, 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 beep. Negative times a negative is a positive. There we go. All right, cool. Negative 2 plus 6 is a 4. And negative 1/2 times 4 is negative 2. And we'll add these together. We get another negative 12. Okay. And then half of negative 12 times a negative is positive 6. And we get our remainder of 0. So I did mention earlier that you want a remainder of 0. If you get a remainder of anything else, could be 1, could be 3, could be 7 billion. It's not a solution. You have to try something else. So 1/2, so our solution so far, x equals positive or negative 1/2. That's great. Okay, awesome. Now we've reduced it down to a cubic. So I'm going to go ahead and change pages. So that's 4, negative 12, 4, negative 12. And we're going to try the positive 3 first. Drop our 4. We get 3 times 4 is 12. Add these together. Ooh, we got a 0 soon. Okay, 3 times 0 is 0. Add these together, I get 4. And then 3 times 4 is 12, and we get another 0. Okay, great. But we get our remainder of 0, and that's what's important. Okay? Okay, so reflecting. Positive 1/2, negative 1/2, and 3. This is the big reason why I like to use synthetic division. I've reduced it now down to a quadratic. So I told you the other solution might be negative 3. Well, we could probably double check without any hesitation that negative 3 is not going to be a solution. So what are the additional solutions? Well, we've got it down to a quadratic, and specifically a quadratic with no linear term. We can just use some algebra, or maybe you want to use a quadratic formula. That's up to you. So this would be 4x squared plus 0x plus 4 would be how you'd write out this quadratic. Of course, let's just simplify it a little bit and just say plus 4x equals 0. And let's go ahead. Oh, no, sorry, minus 4. Okay, subtract 4. We get 4x squared equals negative 4. And then divide by 4. X squared equals negative 1. And then we'll take the square root. And of course, square root of negative 1 is plus or minus I. And so that leaves us with all our solutions. So in short, let's recap really quickly. With the rational zero test, we're going to write out the factors of the constant. Okay. Again, don't have to write plus or minus, but you have to keep in mind that negatives are possible. Then we write out the factors of the lead coefficient. Then we create ratios by systematically going through all possible combinations of R and S, and again, plus or minus. Then what I like to do is use synthetic division until I've reduced it to a quadratic, and then either use algebra or quadratic formula to find any remaining solutions if they happen to be complex or irrational. Now, we got lucky with it. Well, we didn't get lucky. I designed this problem, so we didn't get lucky. But we got a problem where this plan could be executed flawlessly. What happens if we go through this entire list and we can't get it down to a quadratic? Well, then we have to resort to other methods. And other methods that may be useful will be coming in future videos. Maybe you get an opportunity where you can do factor by grouping. We could have done factor by grouping with this polynomial right here. Okay? There are other things we can do shown in my previous videos and that will be shown in future videos. But this is kind of like the dream situation where you can reduce the polynomial down to a quadratic and get any additional solutions from there. Anyway, I'm rambling at this point. Thanks for watching. Have a good one.